Hello friends, welcome to my channel. Today I will be discussing Leetcode daily challenge problem. Problem number is 135 and name is Candy. And it's a hard level problem. First, let's read the problem. There are n children standing in the line. Each child is assigned a rating value given in the integer array ratings. Means we have been given an array of ratings which denotes the rating of the children which are standing in a line in a queue. You are given a candies to these children based on the following requirements. Okay, let's read the requirements. Each child must have at least one candy, means that every child must contain at least one candy. There doesn't exist any child which does not contain any candy, means the number of candies for any child is greater than equal to 1. Okay, children with higher rating children with a higher rating get more candies than their neighbors. Okay, they're saying that if my neighbor has a higher rating than me, then my neighbor will get a higher candy than that I have, and we have to return the minimum number of candies that you have to distribute to the children. Okay, so this is the question, and first let's come to the first example. It has given ratings array equal to 102. Okay, so see, let us write the first example here. Let's use blue pen. 102, this is the rating array which is given to us. Okay, now see, we will maintain an array of the same length as that of ratings array and we will initialize each and every element of the array by 1. Okay, 1. Okay, we will perform two traversal here, because first we have to check for the left neighbor, and in the second traversal we have to check for the right neighbor. Okay, so in the first traversal we'll check if ratings of, let me write ratings as r of I is greater than r of I minus 1. Okay, if this is the case, then the let denote as c of I equal to c of I minus 1 plus 1. Okay, in the first case we will consider the left neighbor of the particular index. We will start from the first index, because if we will start from the 0th index, then it doesn't have any neighbor and we will get a segmentation fault. So we'll start from the first index. Let me name the index as 0 1 2. Okay, so see, we are starting from this index and we will see. We'll see whether 0 is greater than its previous neighbor, which is means left neighbor, which is 1. No, this is not the case. So we'll iterate to the next iteration. Now our iteration comes to 2, second index, and we'll check whether the index at this place is whether the rating at this place is greater than the rating at the previous left neighbor. No, yes, because here the rating of the second index child is 2 and the rating of the first index child is 0. So we have found the case where r of I is, our first condition is true. Okay, so we'll increase the candies of the particular second index, so it will now be converted to 2. Okay, and in the second iteration you will do this. See, you will check, you will start from the second last index, because and you will check whether we will consider the right neighbor here, whether the particular index child has greater ratings than the right children, and if this is the case, then we will increase the candies of the particular children. See, if r of I is greater than equal to r of I plus 1, so it's not equal to r of I plus 1, and if this is the case, then you will increase the candies counter. But there is a catch, that whether the candies existing at the particular index is greater than the candies which are to be updated. So see, we will update the candies as maximum of C of I, whether the candies existing in the previous iteration is greater than the candies which is to be updated next. So C of I plus 1 plus 1. It helps in keeping the track whether we have the maximum candies at each index. So see, we'll iterate from this place. I've said that we will iterate from the second last element. So we'll check whether its rating is greater than the right neighbor. No, because its rating is 0 and the right neighbor has rating 2, and this violates our case, so we'll not consider this. And now we'll come to the 0th index and we'll check whether a rating of 1 is greater than 0. Yes, it has a right neighbor which has less rating than the particular index, so its candies need to be updated. So we'll check from this formula. It's 1 and C of I plus 1, which is 1 plus 1, and we have to consider the max from this. And if you will consider max, then it is 1 comma 2 max, which comes out to be 2. So we'll iterate change here and will come out to 2, and at last you will return. You will iterate over this vector array that you have created, and you will add all the elements existing here, and it will come as the count of the number of candies required. So the final answer of this question is 5. 2 plus 1, 2 plus 1 plus 2, which comes out to be 5. So this is our intuition to solve the question. Let's check out its code to see. First we have found the ratings array size, and we will initialize a candy array which of size n and initialize all the elements by 1. Okay, see here. Now we will iterate from the first index and we'll check whether it has the rating which is greater than its left neighbor. For left neighbor I use I minus 1, and we have firstly found the candies which is candies of I minus 1 plus 1, and in the second case we are checking that we are checking from the, in this case let me write here left neighbor, and in this I'm checking for right neighbor. And at last I'm adding all the elements and getting the answer. Thank you friends. If you like this solution useful, then you can like, share and subscribe to my channel. Thank you friends.